In this video, finite friends, we are going to start exploring this concept of a system of equations. And in this particular unit, we're going to focus on a lot of different techniques for solving them. So a system of equations contains at least, oh boy, at least two variables and two equations. And a solution to a system is values of variables that satisfy each equation of the system and every equation of the system. So solving a system using graphing is one of those things that you learned in Algebra 1 and Algebra 2, where you graph both lines on the coordinate plane and you look to see where they intersect. Okay, now I'm going to be honest with you. This solution method is not really all that preferable or efficient. You're going to run into three scenarios when this happens, when you put two lines on the plane. You're going to get either one solution, which is the location of where the points meet. You're going to have this scenario where there's no solutions, and that makes sense because the lines here are parallel and they will never ever touch. So if you're looking for where they touch and they don't, then there's going to be no solution. And then this is many solutions here. And the reason why is because you're getting the same line just pretty much imposed right on top of the other. When you go to graph the two lines, you're just graphing it twice. Let's take a look at maybe some solving by graphing here. All right, so if I were to graph this system, I'm going to start by graphing this particular one in blue. So intercept of 3 and then down 5 and over 3. So there's 1 point, and I could go ahead and draw my line that goes through there. And then I can do the same thing except graph this one in red. And slope of 1/3 leads me, oh hey, that was pretty easy. Okay. And now that I know where the solution is right here, I could just simply pluck the coordinates of that point as 3, -2, and there's my solution. Okay, let's do this with the other one here, 4x plus 3. That's going to take me off the board, so I think I'm going to go down 4 and left 1, kind of like what we talked about in a previous video. And then I have the line -x minus 2, which means it's going to go through that particular point. Hey, there we go. That's our solution right there at -1, -1. Okay, so this seems like it's a pretty easy method to do, except there's a lot of drawbacks to it. One of the drawbacks is that you're relying on the accuracy of your graph. And I'm going to point out that even yours truly dealing with this particular technology of drawing lines on an iPad, you can see that it's not all that straight. And if you make a mistake in applying your slope, or you don't graph the y-intercept correctly, then you run the risk of having a really big problem here. So graphing to solve a system is not preferable. What I would almost rather say to you is, maybe try this a couple of times just to find out how miserable it is on your own. And I would say that I don't think we're going to graph to solve more so than we're going to use the graph to say, oh, hey, that's where the solution is. And realize that there's a connection there. And we're going to explore that connection for sure in this term. Here is, oopsie. Now, you've already learned a couple of methods for solving systems algebraically. One is called substitution, and the other is called elimination. And sometimes elimination goes by a different name. Sometimes they call that linear combinations. Now, I prefer calling it elimination because it's much more hostile to call it elimination, quite honestly. So, both methods can be used to solve any system of linear equations, and you get the same answer if you do so. But one method will typically be a better choice based on the problem. So as I bring this to our attention here, what I'm going to say is we've got this substitution situation where we've got 4y is equal to 8 minus 3x, and y minus x is equal to 1. In substitution, what you want to do is get a variable all by itself, and probably the easiest way to do that in this particular problem is going to be to get the y by itself. So I'm going to effort to get the y by itself here, and a little trouble with the controls here. Y is equal to x plus 1. All right, so that means that the y is all by itself. Now what I'm going to do is I'm going to take this expression and I am going to substitute it for y in the other equation. And in doing so, I'm going to knock myself down to one variable. So it's 4 times x plus 1 and 8 minus 3x. And now we can solve this much easier than we might have before. Okay, so let's get the 3x moved over, and we'll take away the 4, just kind of try to do this very efficiently. And we come up with, we come up with 4 over 7 is the answer. That's just gross and disgusting. Too bad. Wish I knew where my sound effect machine was. We could boo this. Here it is. Let's give it a boo, shall we? Probably a smart move to give it a boo. Okay, so now what I do to find the other part of this, because every solution has an x and a y, we're going to put that in here. And honestly, this looks like a football play that Mr. Carlson drew up. 4 over 7 plus 1. Let's change that 1 to 7 over 7 to make the addition easier. And 11 over 7 is your y value. So the solution to this system is 4 over 7 for x and 11 over 7 for y. And I prefer it as an ordered pair because, selfishly speaking, it's easier for me to assess that if you are doing the problems that way. It's just easier for me to grade. Can't talk again. All right, now let's talk about elimination. And elimination is kind of an interesting technique because you can see different ways of even doing elimination. But the big idea here is you're going to add the two equations together and you're going to eliminate one of the variables completely. Now, here we are set up for elimination right away because if I add these two equations together, the y variables will drop out completely. And when I do that, I'm going to be left with negative x is equal to negative 6. And that's going to allow me to solve this for x in a quick hurry. So x is going to be positive 6 when I divide everything by negative 1. So now I do have to go back and substitute this into one of my equations. It doesn't matter which one. I'm just going to pick the top one. You could certainly pick the bottom one if you wished, and you would still get the same answer. So you get 2 times 6 minus y is equal to 9. 12 minus y is equal to 9. Take away the 12 from both sides, you get negative 3, and then finally divide by negative 1, and you get 6/3 as the solution to this system. That was pretty slick and pretty fast. Okay. Let's try a couple more here. Now, I want to point out that on this first example, look out, you don't have your x's and y's on the same side. So I think what I'm going to do is I'm going to move that 2y over to the other side. And as I do that, I notice that I am going to be able to eliminate the y's almost immediately. So I'm going to go ahead and do that, add those two x terms together to get 11x, and the y's are knocked out, and I've got 33 here, and quickly dividing by 11, x is 3. Okay, good. So that wasn't too bad once we knock out the knock out the y. But now I've got to go back and solve for it. So I'm going to take that 3, move it up here. So I have 3 plus 2 times y. Oopsies. Let's just call it 2y instead of the parentheses. And then take away 3 from both sides, you get 8. Divide by 2, you get 4. And the solution to the system is 3 comma 4. Okay, not hard to do. Where things get a little bit hairy with elimination is right here in situations like this, where you can't add these together and get rid of a variable right away. Sometimes what you might need to do is you might need to put this in a situation where you have to multiply one or both equations by a number in order to get them to drop out. You can make your choice here. You can eliminate x or you can eliminate y. Me personally, I've had it up to my neck with x, and I've had it with his nonsense, so he's got to go. In order to figure out what I need to multiply by, I'm going to take the common multiple of the coefficients 4 and 5. 4 times 5 is 20, so that's the common multiple. But I want 120 to be positive and 1 to be negative. So I'm going to multiply this top one by 5 and this bottom one by negative 4. And as I do this, I'd like to point out that one common mistake here on elimination is not distributing to every part of the equation. That is something that you need to do to avoid disaster. So negative 20x plus 25y is equal to 5. You do have to distribute to all parts of the equation. That's the reason I put it in parentheses, so I wouldn't forget that, because I'd hate to see that happen to me. So 20x minus 28y, and then that's negative 20. And then while we add pretty quickly, we get negative 3y is equal to negative 15. The x terms are knocked out, just like we planned. And then y is going to be 5. Okay, not so bad. Let's go ahead and dump it back in and see if we can get some information here. So I'm going to put it into the top equation. Negative 4x plus 5 times 5 for y is equal to 1. So negative 4x plus 25 is equal to 1. Negative 4x equals negative 24 when we subtract. Divide by negative 4 and stand on your head, and you get a result of 6. So 6, 5 would be the solution to the system. All right, in this panel, we're not going to really focus on the actual solutions, more like what method would you use. Okay, so for this first one over here on the left, the strategy that I would use is elimination, and I'll tell you why. I don't see any of the variables that have a coefficient of 1. I don't see any variables that are just an x or just a y with no number in front. And that's probably the signal for me to use elimination, because I figure it might be a little bit faster for me to get rid of a variable than to try to solve. So I would likely use elimination here. And for this particular problem on the right, I would likely use substitution because the x is already isolated in one of those variables. Now, I also notice that there's no number on x. So if you see a variable that doesn't have a number on it, you may want to solve for that one first and use substitution. Either method produces the same answer. There's no wrong method to pick here unless you're going against the directions of the problem. So I can tell you that on the test, there's going to be some problems where I ask you to solve by substitution, and some where I ask you to solve by elimination. And there may be another problem where I say your choice, whichever you prefer. So that is definitely something to think about. Make sure you practice each particular technique as you go along, and that'll help you to just kind of round out your choices, and you'll make good choices when it comes to picking out which method you wish to solve efficiently. Okay, now there's a couple of situations that we're going to run into where disaster may strike here. And if the variables cancel out and each side of the equation is equal, then there are many solutions. Sorry for being the grammar police there, but I had to do it. And if the variables do cancel and each side of the equation is not equal, then there's no solution. This is sort of similar to what you did with regular equations. If everything drops out, you get something that's true. It's many solutions if the variables cancel and each side of the equation is not equal, then there's no solution. So let's take a look at a couple of those to wrap up our discussion here. All right, a couple of special cases here, and I'm going to start with the one on the left, and I see that this is already built for substitution because I've got one variable that has already been isolated, so I'm going to go ahead and just jump right in with substitution. I'm going to take this entire expression that I've highlighted in green, and I'm going to put it in for the x in the second equation. Okay, so 2 times 12 minus 3y plus 6y is equal to 24. All right, so 24 minus 6y plus 6y equals 24. And we notice right away that the variables are going to drop out, leaving us something that is true. This means we have many solutions. So before I go on, though, my math lab is going to be a little cranky about how they want this solved. They might say something really weird that says, express your answer as an ordered pair. Okay, well, how would you express your answer as an ordered pair when there's many solutions? I mean, it's going to be a while for you to list them all. In mathematics, sometimes what we do is we just use variable expressions to catch all of the cases at once. And my math lab is going to probably present it as x comma something, and you have to fill in that blank. Well, you want to make sure that everything is in terms of x. Okay, so you got to get your y in terms of x to solve this problem. Okay, well, how would I do that? I'm going to take this second equation here and I'm going to solve for y. And when I divide by 6, that's going to be negative 1/3 x plus 4. So that part right there is what goes in the blank. So I'm going to highlight that in red and then write that in red here. So my math lab is probably going to have you express your answer like this. It seems like it's a little strange, but the reason why they do this is because when you have many solutions, you have what is called a dependent system. Okay? And a dependent system is one where all the solutions depend upon whatever your choice for one of the variables is. So if you pick 0 for x, then 4 will be the solution for y, because negative 1/3 times 0 is 0, 0 plus 4 is 4. Pick another x and you're going to get a different y. Pick a third different x, you're going to get a different y. So everything is dependent upon your choice of one variable, and then the other variable is sort of locked in based on what we solved for in red. Okay, so that's going to be a way for you to handle that with many solutions to a system. Now, over here, let's solve this one on the right and see what we come up with. I'm going to have to do elimination, and probably multiplying the top equation by negative 2 is a smart move here. And trying to get rid of one variable, I wind up getting rid of all of them, and I get left over with 0 is equal to 10. Now, we all know that's absolute nonsense. So since we have things that are not equal, this is no solution at all. Okay, so now we've kind of done a quick review of substitution, elimination, and also how to handle some strange cases.